Okay, so now what we'll do is we'll spend a bit of time on the new liquid effect. I'll try and show you some different things in the video that I sent the other day, walk you through. In this case, you may want to jump in and ask questions because I have covered most of this before in a recent video, so it's an opportunity to be a little bit more interactive. So in this case, I've got an audio track here, and I wanted to start by showing. So first of all, let's flip this around the other way. Let's move this to the bottom of the screen. Let's change it to 90 degrees so it's actually shooting up. Let's reduce the flow down significantly, maybe a little bit more. There we go. And let's drop the velocity as well. Still a little bit high. You can see that it's quite sensitive on the velocity, and then we'll have to drop this as well. So now it's almost like a little fountain. Can't have a red blood fountain, can we? So let's make it blue. Can you see that? Maybe we'll make it light blue so you can see it. All right. So I wanted to demo the audio effect. I've actually got my audio on. Hopefully it's not too loud, but let's play it. Oh, hang on, sorry, let's set it, flow matches the music. So let's play it. Oops, maybe it's a little bit too light. Maybe we'll get up to 6. Actually, I'm gonna make that even higher, 50, that's better. Okay, so we'll play it again. Velocity's a bit low. All right, let's go back to the beginning. Play it again. So you can see how it's jumping up with the music. So the flow rate in this case is matching the music. So once the music gets quite intense, it just takes off and it goes everywhere. But it's kind of interesting to have it match the music. We'll get rid of that. I'm going to go back and create an animation sequence so I don't have the annoying sound. Okay. So something which I tried to explain in the video, and you kind of saw it then, the flow, the velocity, and the size up here interact a lot to change just how the particles are emitted. In this case, the size is 500 is reasonably small. If you go a lot smaller, you can see that the particles are allowed to get a lot closer together, and as a result of that, they don't tend to move as far, but you can then do things like pump the velocity up, which changes how fast those particles are emitted. In this case, that's not making that much difference. Even the flow is not going to make that much difference, and that's because at this point the particles are really quite small. As you increase the size of the particles, they'll have a tendency to spread out more. So you do need to play with the particle size and the velocity and the flow to get exactly the sorts of appearance that you want to get. So I tend to like the 500 as a size because I think it gives a particle that looks more like water. But it does mean that you need to then lower the flows quite significantly. And as you saw, if you really just want it to be a steady stream, you really need to get the flow down quite low. The velocity can be quite high. It just means it's shooting up a long way and it never seems to fall down because it's going so high. I'd have to get the velocity quite low for it to actually fall back to Earth. Sorry, we'll re-render it. Even at 4, it's still, yeah. There we go. Now you can start to see gravity taking over and it's falling back to the ground. So yeah, you got to play with those. the direction really, the best way to see the direction, if I change the X and the Y and bring this into the middle, and I've got the flow nice and low, so you can see which way it's going. So 90 degrees is going up, 0 is out here to the right, and it goes anti-clockwise around. That's just the way it works. If we were to change this to a value curve, set it to a ramp, which start it from there and go to there. And so you can see how it's moving around in a circle and spreading the water out. It kind of looks pretty cool. It'd kind of be nice if you turn that into a kind of sawtooth or something. I mean, you can send it backwards and forwards. The problem with the sawtooth is you don't really get a vertical. You'd probably have to go to a custom curve if you really wanted to get that to work. But this is now moving backwards and forwards so quickly that you can't really see the movement anymore. But the value curves really give you some very different sorts of effects. Now, if you've got the flow up a little bit, and you put in the barriers so that it can actually start to fill up. One of the neat things that you can do, you can see when it starts there's nothing there and it fills up slowly. Well, what happens if you want it to actually look like that from the get-go? The way you play with that is you change these warm-up frames. And so in this case, we're on a 50 millisecond sequence. So every 20 frames is effectively a second of warm-up. So if I set that to, say, 68, so that's 3 seconds of warm-up. So when the sequence starts, you can see it's all, when the effect starts, you can see the water's already starting to build up. And the reason it does that is because it actually pre-simulate 68 frames prior to the effect starting. So it's a great way to prime your effect and not have to see it always start pretty empty and then fill up slowly, if that's what you want. That becomes kind of important because if you're after a particular effect, let's imagine that I want an effect where something like ink is injected into a black fluid. So the first thing I'm going to want to do is I'm going to want to fill this up with black fluid. So I probably need a bit more flow going on. Okay. Sorry, it renders a little bit slowly. Well, that velocity's pretty low already. But what I can do is there is a setting up here called the Speckle Threshold. And if I increase that, it should give me, yeah, still a little bit. Maybe if I lower that flow slightly. Let's move it to the bottom. Oh, and there's one other thing we should do. We should put a barrier at the top so that it doesn't escape. All right, that looks a bit better. So now you can see how it's all filled up. It's not quite filled up when it starts, so we probably need a few more pre-rendered frames. Okay, and that means that it's nicely filled up. So now the next thing we want to do is change that color to black. And so that's filled it up with ink. And now what we want to do is we want to add a second that's injecting, sorry, it's a second particle emitter. Here we'll move that and we'll place that in the middle at the bottom as well. Actually, no, we won't. We'll put it in the left, in the middle. And we'll give that a different color. Let's make that pink. Okay. So now what we want to do is we'll lower this velocity a bit. It's really working hard to render this. Okay, so now we've got this, the pink coming in, the velocity's probably not high enough. Oh, the angle's not good. The direction's going down. Oh no, the direction. Let's go 45. And let's mix the colours a little, which will produce a finer edge on it. Okay, so the next thing that we want to do is, so now the flow here, which is set to 151, that works really well, except after it's full, we really don't need any more black particles. So let's change this to a custom curve, and let's, very early in the piece here, let's take this down to 0, and we'll take the end down to 0 as well. So what that'll do is it'll stop it from injecting any more blackness once it's done. And then we will go to here. And here what we will do is we'll change the flow here as well, but we'll do the opposite. So again, we'll make it custom. Let's put a point in. But in this case, what we're going to do is we're going to start it at 0 so that the injection comes a little bit into the effect. So the effect starts out black, and then we inject the pink into it. And you can see that the pink slowly comes across and mixes in. So it's like it's an ink, coloured ink injected into water or some sort of fluid, right? Which I think is an interesting way to use it. And it's not incredibly obvious that that's what you can do, but you got to think about it, how it's working behind the scenes, and it is just fundamentally a particle simulation. Now, of course, there's no reason why that has to just be pink. You can go in here and choose one of the color curves, and now the color that's injected will change over time. Starts red, orange, yellow, green, blue, and so forth. So you can get some interesting effects doing things like that. What else did I want to show? There we are using this Speckle Threshold. This wasn't in the video I sent earlier. If we set that back to 0 and re-render it, what you'll see is, see how you get these black dots appearing inside the sequence? That occurs because effectively we're actually simulating thousands and thousands of particles. And by chance, every now and then in one box or one pixel, you'll end up with a black, and so the black shows through. And the Speckle Threshold lets you remove those speckles. And what it basically does is it looks at every pixel around it, and if everything around it has a color, it will then override the blackness and fill it in, and that gives you the much more smoother effect that we were looking at there. Lifetime's interesting as well. Lifetime basically controls how long particles live. Now, this is going to be an interesting challenge because by setting it to a limit, you can see that the black ink, so first of all, our color starts to fade away over time, but also that black ink that we were merging it all in with is also disappearing after, and the time is in hundredths of a second, if I remember rightly. So this is going to disappear in about 1.37 seconds. And so it kind of degenerates over time as all of that background particles disappear. But again, it produces a slightly different effect. You know, that on a tall tree, I think would be quite an interesting, it's almost like a flame. Changing the particle size just drives up the particle separation. You'll see that in a second when it renders. It takes a little while. Okay, you can see now the effect of the particle size. And so by changing the particle size, it stops the particles from getting too close together. And so you get a much more spread out and a random effect because they're obviously, now they're spread out, all of these things like flow and velocity change dramatically, and so you get stuff that's much more intense and random as a result of it. And so you would have to play with these settings down here because of that change. Okay, so we've talked about most of the things here. We haven't talked about the types. So there are some types here, which in theory, let's change that lifetime back up. The types in theory change the way the particles interact with each other. I must admit that I don't find that the differences are dramatic, but they are there. You know, when it's viscous, in theory, the particles are much more sticky to one another, and so you're seeing that the colours are a little bit more blended out than they were back when we were using elastic, which was the default. We have to let it run a couple of seconds to properly re-render. So you can see when it's elastic, it's tending to hold its shape somewhat. This piece down here is coming out. It gives you a slightly different effect. When you go with powder, the particles don't tend to stick to each other at all, and so you'll get we're starting to see some speckles coming back in because the powder's a little bit different. If you get rid of the mixed colors, that might even be a little bit more dramatic. All right, so here you're not getting it feed in, so you tend to get the colors more spread out and more obvious, less blurred in. So yeah, so play with them. Look, like I said, I find that the differences are quite subtle and not necessarily worth spending a great deal of time worrying about. But look, I'm hoping that people find interesting ways to use this as, you know, backgrounds on other effects and the like. Are there any questions? Because I'm not sure there's much else I can show you that's unique, special, or different about it. A question. How does the size pixel count of the matrix affect the best values for size and flow? Well, obviously, if your model's a lot smaller, then things will fill up a lot quicker, and you'll probably end up using smaller values because you don't need as many particles to get what you want. Obviously, the richer animations like this are going to look a lot better on larger matrices or larger trees. But, you know, I think you have to play with it. My picture looks a lot smoother than yours. Okay, possibly. Not sure why. I'm not doing anything special or different. I'm just setting the values. I am using a matrix here that is 32 rows high and 100 rows wide. So that could be why. I don't actually have a matrix that is that dense. I just find that matrix is a useful size for demoing things on. If I was to go and change it to a much less dense, so if I was to take that same effect and move it down onto my tree, which is going to look a little bit weird because it's going to be coming in from the side on a very narrow tree. But this tree is a 16 strand, 150 pixel tree, which is actually a tree that I do have. And so you can see it looks a little bit different because it's a lot narrower and it's coming in from the sides, but it still looks pretty good. All right, well, if there's no questions, no one wants to speak up, I'll stop the video there and I'll post it.